So, the lesson study that we're presenting today is the one that I showed to you many months ago, and it was about exponent laws and using dice to generate exponent laws. Now, what we did is we started with an example, and what we'd change is we'd do more of a review from last day. So here we have a picture of the power with the base and the exponent, just so students have a review of what that all means. And this would give an idea of the destination of the lesson. So today we're going to see what happens when we multiply and divide powers. We started with an example, yeah. So for our next slide, we went through a dice activity, shaking each one of the dice, and the red one here is the base and the blue ones are the exponents. So what we changed this time is how they were situated. We have the base lower and then the exponents above, just to represent how it would normally look. And we also said we have to remember to be aware of your language. While I was talking here, I said 8 times 8 times 8 times 8 9 times, and it got really repetitive, and I also drew it out really repetitive. So if I was to do this again, I would be really picky with my dividing symbols and my multiplication signs. I would probably use brackets or dots instead of actual X times signs. Now I'm going to teach you more about what we changed in Nicole's lesson. So one thing that we need to do is to watch for teachable moments. So if we just go back to the previous slide, when Nicole was doing this slide, a teachable moment arose because when she did the exponents, there was a bigger number that was supposed to go on the bottom as an exponent. So she had 8 to the power of 2 over 8 to the power of 4, and right away she just changed it and made it 8 to the power of 4 divided by 8 to the power of 2. And somebody asked, I think it was Andrea asked, but what happens when there's a bigger number on the bottom? So in the moment, Nicole just passed it off, but we said to watch for teachable moments. So the way that we would do this is through an example of the good guys versus the bad guys. So here's Nicole and I here to save the world, and Rick is here to terrorize. And so the way that we would do this is if we go back to the dice, or so if we had our 8 to the power of, that green doesn't show very well. If we have 8 to the power of 2 over 8 to the power of 4, right away we're just going to talk about good guys and bad guys. So the people on top, they're the good guys, Nicole. And the people on the bottom, they're Mr. Rick. There's 4 of him. And if we got into a fight, Rick is going to win. There's more of him than there are of us good guys. So what happens is the bad guys outweigh the good guys. So there's 2 more bad guys on the denominator. So we would be left with 1 over 1 over 8 to the power of 2. That would be just a quick way to explain to students what happens when there's a bigger exponent on the numerator, or the denominator, I mean, sorry. So, one of the next things we would change, if we move to the next slide, is more language issues. So, what I originally said is let's try an example to test your theories. Well, the students don't actually have theories yet, they're just generating ideas of what they're going to do. So here, we're going to take the word theories and we're going to throw it in the garbage. And replace it with ideas. So we're going to try an example to test your ideas. Then we'd go through and finish the example. So the next slide, same thing. We're going to replace theories with ideas. And here again, you have to, or what I should do next time, is watch my
make my examples neater. So I had my division sign wasn't all the way through underneath all the 8s, and I have to use dots again instead of the actual multiplication x signs.
On this slide, it was more of another example for the students to try out their ideas and things versus a teaching moment. So we asked the students, how many different ways can we group this? So we asked them, what if we put in brackets here and here? And so then we'd have brackets here and again here. So we would have -2 to the power of 4 and -2 to the power of 7. So each time they would find that they would come back to 2 to the power, -2 to the power of 11, no matter where they grouped their brackets. So there they have 2 to the power of 6, -2 to the power of 6, and -2 to the power of 5. So we're left, we find again that -2 to the power of 11. This is something that the students would work through on their own, but we are just showing you for this case. It's just all added in. And this, we didn't change much with this. It was just another example for the students to do on their own as they were working on it. We would walk through and see how they were going about the question. One thing that is a little different with this is in the ones before, I didn't do the times sign, I just did the brackets. So we could take that out just to make them all the same. And we really like this slide because can you think of another way to solve the problem? And when I actually did the lesson, the other way I came up with was actually multiplying -2 to the exponent of 4, getting the whole big number, and then multiplying it again by -2 to the exponent of 7. And so they realized that that takes a lot. If you have a calculator, I guess that works, but it's a lot easier to just do the quick calculation in your head. And then we ended with thinking of some benefits of using the first method versus using the second method. And this just gets students thinking of the different things they could be used for. For example, expanding it will work better when you're adding different